This is Typescript Deep Dive with me, your host, Goble. Hopefully that is the talk you intended to see. Who's talking to you today? I'm Waller. My pronouns are he, him. I'm a boot camp grad. We got any other boot camp grads in the chat? There we go. Represents. This was my first conference talk I ever gave. I've now given it a couple times, so I'm probably a lot better at it than I used to be. If you want to engage with me, I recommend Twitter or LinkedIn. My Twitter's Waller Goble. Currently, I am at Microsoft building Bing and Bing accessories. My last project was Bing Chat, if you heard about that. It was a little weird. Feel free to talk to me about it later when I'm not in front of a camera. Why this talk? Why did I make this talk? I used to hate TypeScript. It made me so angry. And I was like, this is useless. Why would I be here? Why would I be doing this? JavaScript was just fine. I just didn't, I figured like there was something missing. So I thought maybe I just didn't know everything I could do. So I kind of tried to dive in. And it was pretty hard, especially like when I made this talk, there were a lot less resources. And it was pretty hard to understand a lot of things. So I wanted people to suffer less in that process than I did. So I brought my learnings together in this talk. What this is not. I won't be selling you on TypeScript. This used to be harder to sell, but at this point, can I get hands for who uses TypeScript in their job? Yeah, it didn't used to be like that. I started because I was in Angular. And yeah, now it's kind of, it's crazy how fast it's grown. But we won't be going over basic types or how to use TypeScript. We'll kind of assume that you've already done that because you're all using it every day at work. What we're gonna do here is, you know, like that one coworker who makes the insane type and you're like, what could this possibly be doing? And there's no real way to know. Hopefully after this, you will be closer to doing that. I can't promise anything else, but I can promise you, you'll see like, oh, infer. That was crazy. So, what it is, we're going to go to intersection types, union types, generic types, map types, any, unknown, never, conditional types, the infer keyword. And we're going to be doing it with examples in the wild. I find like reading things like, oh, a generic type is a parametric type. That doesn't really do anything for me. I need to see one, need to see it work, need to break it, and that's what we'll be doing. If we have enough time, we'll have a code block. Any questions? So let's dive in. Let's see who's got stuff going on. Who can tell me what this does? What? Oh, yeah. Oh, that doesn't help. I always try to do a light theme. Let's try a different theme real quick. Is that a little better? Oh, that's a lot worse. Man, that's so rough. Man, this theme normally is pretty good on these monitors. How does that feel? Is that better or worse? Okay, the developers want the dark theme. Big surprise. Okay. What does this do? Anybody? Truly asking. I don't know either. Just kidding. Yeah. Maybe this makes sense. Oh, let's turn wrap on. Bam. What does this do is T and K extends K of T, where it's a pick of T of exclude key of T of K. That makes perfect sense, right? What does this do? K extends K of T, where T is equal to key of T, and it is an object where key in K is a required pick of T of key. All make sense? Then you don't need to be here. You can leave. You're not getting anything out of this. The point is, these look insane. This is all just gibberish. But we're going to learn some tools. We're going to break these down, and hopefully by the end of this, you will approach one of these and not really just want to cry. No, these are real. I wrote a couple of these. Oh, yeah, I am a machine. So we're going to start small. We're going to work our way up. Once again, I'm not going to tell you what a Boolean is. I'm not going to tell you that you need to make a number a number. But we are going to look at union types. Union types represent a value that can be one of several types. This is straight out of Typefest, an open source library. What is a primitive in JavaScript? It happens to be a null, undefined, or string, or number, or Boolean, or symbol, or big int. So we can use this type and say, hello is a primitive, it's world. Big ol' number is a primitive, it's 900. Object is not a primitive. We'll see that TypeScript is yelling at us. Yeah. And it'll say, this type is not assignable. So, any questions on that? Any questions on what a union type is? Does that make sense to y'all? Yeah, it's pretty good. The thing is, we saw key of before, and that was we saw that kind of recur in our scary types. What does key of do? Key of generates union types by taking in a object type and returning a union of that type's properties. So if I have user, first name, last name, email, ID, and I use user properties as key of user, I can say, is stuff a property of user properties? No, but I know that it's a key of user. So once again, key of just generates these union types in a useful way. By itself, seems pretty useless. But as we see, it'll come to be a building block. There are more kinds of unions. This one is straight from the Node standard lib. This is the buffer encoding possibilities. You may be used to one of these for if you want to take a function that has a set amount of strings that you can have. This is one of the options for you to do that. Would not use enums, but that is argument I don't feel like having on stage. For buffer encoding, there could be ASCII, UTF-8, UTF-8 other way, UTF-16 LE, USC2, base64, et cetera, et cetera. Excuse me. A buffer is hello connect tech, and it takes in this thing. So we see buffer has been deprecated since I made this talk, which is rough. And also, the first time I did this talk, I put this and I said new buffer, and then it's a buffer of, it's buffering the string, please don't ask me about buffers. And then of the encoding type, I only know about types, and I swear to God, someone said, yeah, so about buffers. And I was like, I can't do this right now, man. I'm so nervous, I'm gonna vomit. Please don't talk to me about buffers. But yeah, so that's, string literals are your most used union type. String literal unions are your most useful unions. There are technically number unions, like a dice roll. If I have my dice roll, which is 1, 2, 3, 4, 5, 6, and I try to make my dice roll 20, it's not going to work because I'm not a nerd. I saw you laugh, so I know you are. Any questions on union types? Does that make sense? Once again, we're just getting our building blocks up. Moving on. What's cool about union types is we can use them with lookups. So a lookup type is an access type at given key, also known as an indexed access type. That's nerd speak. We're going to break it down to be a little easier. The real thing is, let's say you import, let's say you're importing some giant React component, and you need a function that generates one of the props for the React component. And you import the types, and you're like, oh, well, that type is technically like an object with this, this, and that. And so I'll just copy and paste that part of the type for my function that generates my props. You can do that. I'm not going to yell at you. Your coworker should, but I'm not going to. But what I would recommend doing instead is using a lookup type. So let's pretend that ID is some insane object. You can say ID type is user sub ID. And so we'll see ID here is a number. But if I change this to, say, a Boolean, let's pretend that makes sense. It's Boolean now. So this is like variables for types. It's like lookup situation. This also works with unions, though, which is cool. So ID and email right now is string or number. Once again, Boolean. And it's string or Boolean. Wow. Don't have to copy and paste. Living in the future. This also works with array types, which is kind of crazy if you think about it. So if we have at Waller Goble, ID 1337, overalls, true. And we have another person who was my boss at one point, Quelch, not a great username, ID 404, overalls, false. If we say, let's say we're trying to, well, what do we think this is going to do? Twitter user, type of Twitter's sub number. You seem like you have an idea.
Yeah, well, it's going to infer the type based off of essentially any of the other.
There we go. So that's what it's doing. If you think about it, arrays are just objects in JavaScript and in TypeScript, I guess. And if we're doing a lookup on number, that's an object, and it's going to see what's at number and give it to us. Pretty crazy. But that leads us to knowing what to do in one of our examples before, which we'll learn later. But yeah, that was crazy. Any questions? Cool. We're moving on. We're after lunch. A little sleepy. It's fine. Intersection types. An intersection types is the combining of multiple types into one type. So it returns a union of objects. You can do this with primitives, but it's not the best idea. We're getting into object stuff now. So let's say I have a function merge that just puts two objects together. It takes in t and u. Object 1 is t, object 2 is u, and it returns t and u. That's how you do the intersection. Union was bar, intersection is ampersand. So what's this going to return? Object 1, object 2. So if I merged an object with name Anushka and age 30, my type of Anushka is going to be name and age. Pretty cool. This is how we can merge some stuff together. This is another one of our building blocks. You're going to see intersections and unions really at the core of anything complex that we do. This is the first point at which we might lose people. I feel like generics are one of the stepping stones of getting upset about TypeScript. Generics provide the ability to make reusable, parameterized, that's not spelled right, high quality here at Connect Tech. They're functions, but for your type system. Take in t and return t is our first example. An identity function, everyone knows what it does. If you've written some functional code, this is really coming in handy. So identity t takes in arg t and returns arg. So here we're saying, hey, this can be anything. This is my parameter. This could be banana. We can make it banana. That's what my instructor always told me when I didn't really understand parameters. It's type of banana now. It's whatever it could be, and we're just saying that's what I'm going to return to you. So identity 1 is a function that takes in 1. Identity string takes in string. Identity handle takes in whatever I pass in. TypeScript is just going to refer to, it's probably like 8 at this point. It takes in whatever we give it. So that's the idea of the parameterized types. That's like generics at its smallest level. YT, I think someone in the C book did it. It's weird. I tried to look into the history of it. T just seemed like a good idea to them, and then they were like, well, now I need a second one. It's U. There's no good reason. I really don't recommend using T and U. I only do it because I know that you will see it in your job. Once we get into our cool example types, you'll see what I think are really good names for parametric types. Another example, one I bet you've used before, a record. So if I have a record, we all know what that is. That's like how to type an object, type a consistent object in TypeScript. Takes in a string into object, that's an object map, and we're reassigning it to type object map. Excuse me. Number map, string number, any map, string any, but we're not using any, are we? See? Be like Jonathan, don't use any. And these are, it's just as easy as you think they are. Strings, or string map, and it won't let you put a number in because it's a string map. Generics can also have constraints. This is what's interesting. This is where we can really start to inform the type system to let us not shoot ourselves in the foot, which is the whole reason we're using TypeScript, right? We want to think less. We want the computer to think more. So here we're telling the computer, I want a type that is getArrayKind. It'll take in t, which extends array of any, and that is equal to t of number. This looks just like what we saw before. what the gentleman in the cool hat told us will get the type of the array. So once again, if we have at Waller Goble and at Quelch, we'll use get array kind of type of this actual array. And now, through that, I have derived my type. This is cool if you got test data. This is my first like, oh, I need that in my code base. And what's cool about this is like, well, one, it's just less typing. It's less over copy and pasting your types, but also it provides us the type safety. So remember, we went up here, we said T extends array of any. It has to extend array of any, or else TypeScript's gonna yell at us. So if I'm dumb, as I tend to be, I'm like, oh, get array kind of number, I guess, whoops. And number does not satisfy the constraint. So it's just saved us, albeit that's a goofy error, but like, that's true, I've done that. Any questions on generics round 0.5? Cool? It's not gonna get any easier. Let's keep going. How are we doing on time? Oh, we're slow. Let's start going faster. A map type. Come on, wrap again. There we go. A map type creates a new type which transforms each property the old way in the same way. It's a way to iterate over types and modify them. Take a look at an example. You may have seen nullable before. This is straight out of the TypeScript standard library. So nullable takes in type T, and for P in key of T, change my object to be T of P or null. What? Doesn't make sense. That is not code. No one, you never read the TypeScript book that told you could do in. You know what I mean? You didn't know there was iteration in your types. So what's going on here? In key of T, we see, well, first of all, we see T of P. We remember T of P. That's a lookup. But we're like, well, where did we get P? Turns out you can use the in keyword. You can use it over union types. And we can generate union types from key of, right? So we got a string literal union of the properties of T by using key of T. Oh, that's going to move it. I don't want that. So we've got this covered. And then we found out that we can use the in keyword and essentially create a variable. Think of like for item in list, right? P is now item. P is each property in T. But that is where the definition is. In yielded that to us. It stuck a variable there for us to use. And then since we know that this is a string, because we created a string union literal right here, we said, look it up. So this, whatever that key was, set it equal to what it was before, but we're also going to make it a union and let it also be null. Put it all together, what does that do? If we use type user, and let's just say we were like, oh, well, now we need to create a user in the database. We need our form to have a partial user. We want to initialize everything to null if they don't save it. And so Tiny Brain would go, okay, well, let's make another object that's a nullable user. But we don't want to do that because that'll have problems. And we have our first thing, so let's say this is our form. I'm halfway through. That's my real email. I really got to change that. Anyways, first name, y'all don't know my last name yet, but I put my email and my ID. And we have a problem here, this is where your TypeScript's like, okay, man, I know, but my form isn't done yet, so please stop yelling at me. But in reality, we can use nullable, and without copy and pasting all the types, we can get a new thing, and we can have null here. And it's fine to reset other fields to null. Let's scroll back up. Who thinks they could write this from scratch right now? That's awesome. Good for you. But we're getting closer to being able to. But also, it's cool, that already is available. If you go into your computer and type nullable, it's already there. TypeScript already gave you that. But we're talking about trying to make our own things. There are more things you can map. You can make things optional. You know about the optional parameter, I hope. You can see this in a function someday where it's a question mark. It'll just default to undefined. Partial does the same thing. So for P in key of T, make our union, set each property equal to P, then add this question mark for T of P. So modify my object to be that optional entity. I see some rubbernecking, so I'm gonna make it a little bigger. Anyways, So here, we have a user. We've obviously left out last name. And it's got this awful error. You know, TypeScript errors are always beautiful and really comprehensible. But last name's not declared here. And then, but if we have a partial of user, it's cool. We have nothing. And honestly, that works fine, right? They're all optional. And that's because map types iterate over the whole thing. You can't really make it a subset unless you do some weird stuff, which we will get into. Any questions on map types? Well, there's a couple more things we can do. You can do read only. That's a keyword. You can notice this is the same thing. Read only makes it to where you can't change things. You can also use this in functions. You can also use this in your regular types. And it makes it to where we cannot change things because my name is not Wilma. And it's a read only property. And here's what's really cool. So we said generics are functions, right? And we said map types are iterating over things. Well, you can compose map types. So what is a read only? What is a partial of a nullable of a read-only of a user? We'll call it a really cool user. So first name is Waller. That's exactly what the type was originally. Last name is null because we have nullable here. ID is whatever it was before, and email is undefined because it could be undefined. But we cannot change anything because we made it read-only. Through composing map types, you can just, this is something you actually need at some point. You can be like, I want a state. I've gotten something out. I wanted to keep it just the way it is, but I know that it can be nullable or undefined. Let's keep it like that. So it's pretty cool that you can compose these. It really helps you. It helps nail down the concept that generics are functions. You can compose functions. You can compose generics. Cool. The last thing we can do in map types is you can actually add and remove modifiers too. So you can Midas read only to make something mutable. I found this through looking at TypeScript source code. And I also learned what's crazier, oh, you can't see it, but there's also plus. There's no reason for it, but whoever added it just had the desire. I can't really tell you. But yeah, that's the cool thing. You can add it. So here's our last thing. Let's try and put together what we've learned. What does pick do? Pick takes in t and k, which extends k of t, so constrain our second generic to be a key of the first generic, also technically kind of defaults it, and say, for p in k, give me t of p. What does that do? Anyone? Well, go ahead. Yeah. He's exactly right. So if I say type test equals pick of A, oh, I got caps lock on, cool, and B, we're going to see that B, our test is equal to number. It made me an object of just the things that I passed in. Now I could pass a union, because that's a key of, and say also A, and now I've got the same thing back again. But if I were to add C Boolean, it's not in there. Powerful stuff. If you know how to read it, if you know how to write it. And we're getting closer. I think we just did that. So I just ruined my learnings. So yeah, here we're going to go into one. We're going to go a little smaller just so we can get in there. Okay. Jonathan, do you know how long I have? 55 minutes. Yeah, cool. So let's do some more learnings. So someone asked about, or we talked about T and U. I would never use those in my own types, and I rarely do. We have this example from the beginning, which is, remember me is T and K equals K, extends K of T equals pick of T of exclude key of T of K. What does that mean? Well, first of all, that makes no sense because just saying K and T and K sounds like key of, and it just gets all jumbled in your brain. So let's use, just like you don't use X and Y for every function name, we're going to use good names for our generics. If we make a type that's called accept, and it takes an object type and a keys type, which extends key of object type, it is equal to a pick of object type, which is an exclude of the key of my original object and my keys. So what does that mean? It's essentially the opposite of pick. Give me everything in a user except ID. Sounds crazy, looks crazy. It's pretty simple and certainly useful. This is exactly that same motif we keep using of like, oh, I'm creating a new user in the database. Well, it doesn't have an ID yet on the front end. So I need the thing without ID. Another one. What does this do? T equals K, which extends a blah, 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 blah. Real thing. Require at least one. So this is a type that is out of a library called Typefest that I rip a lot from. I highly recommend using it. I highly recommend looking at it. It's Syndrasaurus, if you know him, the god of TypeScript open source. This is an awesome type. So what this does, and this is exactly how I'd write this. Create a type that requires at least one of the given keys. The remaining keys are kept as is. So we call it require at least one. It takes in an object type and a key type, which extends key of object type, which is defaulted to key of object type. So essentially it's taking the object that I want to require at least one of. So for key in my passed in keys type, make a map type. And it is required of a pick of the object type and the key that I'm iterating over. So this is the keys that I want, make them required. And then by picking that keys type and making it required, but then do a lookup on keys type of those required keys. Then intersect them by adding the remaining keys, i.e. the ones that I didn't talk about. Crazy, but I've needed this so many times. And one of the things I looked for was like, oh, how do I do this? This is one of my first big challenges, and this guy blew it out of the water. So let's say I'm making some class that he called responder for some reason in his example. It's essentially, it either needs to implement a toText or a toJSON method. And it needs to be secure. So responder is require at least one of text or JSON. So if I have JSON here, but if I do that, it doesn't work anymore because I'm requiring at least one. But I can also implement text, and let's just call it, I think it has to do hi. So it has that, and then also this is fine, right? But we're so good, but if we still get rid of one, bam. Nuts. That's crazy, but that's so useful. Any questions on that? I really want to hear if anyone's thinking about it. Don't be shy, don't be nervous. Tell me how you're thinking about this. Does this seem useful to you? Yeah. Well, slides will be available at the end. Feel free to steal it where I stole it from. Yeah, so you're learning something. Does that feel a little more safe to anyone? Like way better than the first slide, right? We're learning something. We're going to blow through the next couple slides because I don't really like them as much, and then we're going to get to the even crazier stuff. But this is supposed to be a break because what we're going to learn next is much harder. Any, who knows any? You shouldn't. Any is TypeScript. I got it, man. I'm only a little drunk. I might steal that joke. Oh, that's really good. I gotta write that down. Anyways, it's just thrown out the window. You know what I mean? Like, I don't want TypeScript. I got an object, it's whatever. I got a property, it's probably a string. And just give me whatever else I want. And I'm just returning that property. This could be this could be anything. It could be Boolean. And it's just not gonna matter. It's not gonna care. No one's gonna love me. It's just any. It's just whatever. But yeah, and so here we can just say that's Boolean. It doesn't know because we didn't tell it anything. We told it TypeScript, don't think about it, don't learn about it, just look. Here's my recommendation. I use any all the time. It's kind of a facade. You have to balance as being a developer, and I'm sure many of y'all know this a lot, but like productivity versus perfection, right? If we don't ship anything, we don't get paid. But if we write bad code, we can't ship anything and we don't get paid. So we want to be in the middle. And I learned this from an awesome talk by someone named, I always say their name is Brie Larson, but it's definitely not. It's Brie something. She works at Airbnb, and she did an incredible talk about how they turned all the code at Airbnb to TypeScript. And this is the #1 thing I got from that. Use fix me. So this is just a type alias. You all know what that is. But use this, import it from a single place, and then you have a programmatic list of your tech debt. It's like a programmatic type level to do comment. And so you can, if you're like, I don't know, man, React's being lame. I understand that it wants children from specific children type, but I just can't figure that out right now because my boss is yelling at me. Fix me, move on. But it's helpful to be able to refactor it. See, this is the exact example. That's really fun. I forgot that, but like getting React to understand children sometimes is just so annoying. But yeah. So if you take anything away from this talk, put a fix me in your repo. It really will help. And it's also like you're bored on Friday, you really don't want to work. It's like I'm gonna go tackle some fix me's. And I say that there's also situations where any is what you want. Is anyone familiar with like functional programming? Yeah. So you know what a compose is. A compose takes in a function and like it creates a function that takes your data through a series of functions. And it turns out if you only care about what goes in and what comes out, you really don't need to know what's in the middle. So this is a perfectly valid way to type compose with because you're never going to know what's in the middle because you can't know everything that they typed in. So once again, the lesson learned is type pragmatism. And then I have the awful pun of any questions? Moving on. Unknown, it's like any's cool. It's the guy. It's like any, and the guy that told you not to worry about is unknown. It's a much cooler any. So unknown is like, hey TypeScript, I know I don't know what I'm doing. You know I don't know what I'm doing, but check me on it. Don't let me BS you. So, you and I know this is 5. You know that this variable is 5. The computer doesn't because we told it we don't. It's like, hey, you know it's 5. Even you know it's 5, but it's unknown. So if I have a function that's just add, we all can imagine what add does, I hope, and say, it says, hey, I don't know, man. You said this is unknown. I can only take numbers. But then if we prove to the computer that obviously a number is a number by saying, hey, well, really it's like if it's type of number, it's cool, it'll let us do it. So if you're going to any and you think you have an any and you can't use unknown, probably a much better situation. I feel like one of the biggest places I use this is in errors sometimes. Wait, oh yeah. Let's pretend we just have a specific error and we have some math. We have a function that throws an error randomly. Error, where you see this a lot, is error is defaulted to any sometimes. But there's actually a compiler option to set error equal to unknown by default. Could not recommend that more, almost as much as fix me. Because you really don't know what you're doing, and errors in TypeScript can be really annoying for this. So, we want unknown here because then the error, like when we're checking our error, it can't just blow up again. Moral of the story, use unknown. Moving on, because once again we want to get the cool stuff, and I'm afraid we're going to run out of time. Never is a type. We need it for our complex types. We just have to go over it. Never represents the type that will never happen or represent anything useful. Throwing an error, like a function that only throws an error, we know that this is never. If we type something as never, you're probably doing something dumb because it's like, well, you can't use it because it's never. Can't, impossible, it's never. Why we have this, it's almost as useful as the plus from before. But it actually turns out we really need it in conditional types. This is where we start to get a little crazy. Anyone here feel like they have a good handle on conditional types? Anyone feel like they've heard of conditional types? Yeah, you've heard of it, but that's why you're here. Like maybe he'll figure it out. So conditional types express non-uniform type mappings, is something a Haskell developer would say. Selects one or two possible types based on the condition expressed as a type relation test. So we already went over variables in typing. That's type aliases. We went over iterating in typing. That's map types. We went over functions as types. That's generics. Conditional types, if you can imagine, are if statements. They follow the pattern of kind of looking like a ternary operator, one of the things I really think is really weird about TypeScript is they like use JavaScripty syntax in their type DSL. So it just looks crazy. You're like, oh, is this code? What's going on here? I don't know. But anyways, conditional types follow the pattern T extends U, if so, X, otherwise Y. So exclude. Exclude from T those types that are assignable to U. So T, you take in T, you take in U. Does T extend U? Never. That means, hey, exclude can't do this because it's already a thing of the thing. Otherwise, give me T. So if I give you exclude of 1, 2, 3, 4, and I exclude 1, 3, what is that going to give? 2, 4. True. That's not very useful because, as we discussed, we're not building dice rolling applications. User properties. Key of user, you remember this. What if we exclude, what if we use properties without user, exclude key of user with ID, we're getting everything else. So that's the most basic conditional types we can get, but it's about to get a little crazy. And that's actually why Ben walked in at the perfect time, because he wants to know what infer does. This is where things get crazy. Whoa. Put complexly, infer is pseudo-pattern matching on types that is only usable within an extends clause of a conditional type and can only be used within the true branch of a conditional type. Infer is actually variables in our functions, in our conditionals, if we're using our normal coding language for this. When you see infer, think of it as the same way you learned how to set a variable. It's like, hey, I got a box of memory in the computer. I'm going to name this blank, and you're going to put whatever comes in right there. But the problem is there's no equals. It feels icky. So we're going to go through some types that already exist. Return type, as you can imagine, gets the return type from a function. So it takes in T, and the type is equal to if T extends any function whatsoever. So this is the most broad definition of a function, right? That's what we're looking at right here. Except, so the most broad definition of a function is takes in a variadic list of any and returns any. But we're saying T extends any function whatsoever, and that function returns infer R. So whatever we pass in from T, take in what would have slotted in at infer R. If we met that conditional in the true block, this type is equal to R. Otherwise, if we did not meet that conditional, never. What are you talking about? You gave me something that wasn't a function. You're drunk, go home. So, if we take in a predicate, which is type T, and it is equal to arg_T returns a Boolean, right? A function that returns a Boolean, given whatever. Predicate's return type of predicate of any, what is this going to be? Boolean. I'm going to say bye to the people in the thing and come over here. No, I'm not, because I did that. So once again, infer grabs R. So right here, infer, and we captured Boolean, and that's what happened here. Does that make sense? Yeah, you think it does, but then you read it and you're like, what the hell? But this is as easy as it can get. So let's hope that we can help here. So testing is just a number. Testing return type is what? Never. Because we went into the wrong block of our conditional because it did not satisfy our constraint in our conditional type. So it doesn't work. In reality, we would add a constraint here, but I did that so that we could prove this example. Cool. So triple return type, what's it going to be? It's going to be number, because this obviously returns a number. And TypeScript knows this returns a number because it took in a number and multiplied it. And it says, okay, I know that. So when I pass in triple here, I'm catching what's in return, setting it equal, and that's the type that you're going to get out. Pretty cool. You're like, Waller, what is this useful for, though? And we'll get to it. Have you ever needed the type of the first thing in a tuple? I feel like tuples aren't very fun in TypeScript, but they technically exist. They're technically supported. So a first takes in T that extends any array. So in the same condition, this is what should have been above, right? We never want to not pass in a tuple here. or an any array or whatever. So we're keeping it in. So T extends, and once again, this is where a type should be, but in reality we're saying, hey, this is infer block, so we're catching something. We're setting a little trap. Whatever array you pass me in, infer the first element and set it equal to U. And then I don't care about the rest of it. If that happened, and we know it will happen because we constrained our type to only be that, yield U, otherwise I don't care, that'll never happen. So tuple takes in blah, blah, blah. This just creates a tuple type as TypeScript likes it. So my tuple is a number, a string, a number, and a Boolean. First of tuple is first of type of my tuple, string. Pretty cool. You didn't know the TypeScript could do that. Maybe. In practice, if we have any Next.js users here, you may remember infer get static props. Have you used that before? Have you ever wondered how the hell it does that? Well, you're about to not wonder. Maybe. So T extends our generic of get static props and infer P. So like whatever you pass in, you can have infer anywhere really after extends. Infer whatever they passed into P, and I don't care about the second thing. If that worked, if it extends that, then it's P. Otherwise though, go into another conditional type where T, the thing you passed in, does it extend a function that takes in a context, which is a get static props context that I don't care about, and then returns either a promise of a result of infer P or a promise of a get static props of result P. If it does that, once again, we're in a new conditional type, we're in a new true branch, so we can get a new infer. We have another chance of inferring and popping that P into place. If so, give it P. Otherwise, what are you doing? Why did you pass me this? Crazy, but this, I mean, this helps you every day, and this was really annoying to do in Next before they had this. So, this is what we're learning. We're learning that TypeScript can really amplify our productivity by letting us really not shoot ourselves in the foot and not have to copy code everywhere. You can really have a very clean TypeScript code base if you have some of these things. Yeah. I'm trying to decide if time is fine. Yeah, we're good. We're good. We're good. I definitely know how many slides there are. Anyways, take a second. Deep breath. I'm going to have some sweet tea. I'm going to have some iced tea with lemonade, like we're not in the South. That's not sweet enough. Any thoughts? I would love to hear. I do love my compatriot in the hat. Anyone have any thoughts about this? I want to talk to a human being for 1 second. Do you feel like you understand infer? Ben? Infers things? I don't know. I really think they should have made it let. But I think they probably needed a new keyword for the compiler. I think infer's name is part of why it's so bad. But it is, I mean, like, if you really, I've thought about that. I've had that exact same thought, and I couldn't think of a better thing other than let. And I thought let would probably blow the brains out of, like, someone who just, like, sees that in the wild. It's like, what do you mean there's a let in there? That's not code. That's types. They're wrong, but that's what they think. So, yeah, I don't disagree. The box analogy is the really only thing that broke it open for me. And I only thought, I was like, it's kind of just a variable. I was like, that's what a box is. Oh, man. But, props without ref. You've seen it. You love it. Maybe you don't like refs. This is the old refs. Yeah, this is straight out of Types React with that comment. If ref extends key of P, so if ref exists in the key of P, pick P and exclude K of P without ref, and if so, it's P, right? Props with ref, however, which we need because we have that, this is how we make sure that props do not include a string ref, right? So like, this is a very concrete example of something that you could have in your code base. It's like you have this old thing, you have these old types, but you need to migrate to these new types, and you need a helper type to do that. That's what they do in the React code base, because they decided refs for something completely different, because the initial ref implementation was rough. So, same thing, ref extends key of P. So if we've got a ref going on, then check if P extends an object that has a ref and infer what ref is. So we've now caught R, which is ref, which is our ref type. It could be string or it could be the new ref. Now, if string extends R, so once again, we've just got this R now. We can play with it, do whatever we want. If that's true, then give me a props without ref of P and give me an optional of the ref object and exclude whatever the thing that was set to R and string. This is a typo in the code. First true branch of the conditional using the inferred R. Otherwise give me P, otherwise give me P, otherwise give me P. So what this says is like, hey, if there's a string ref in here, rip it out. But this is a concrete usage of infer that you could easily have in your code, and you technically do have it in your code because you have the React code in your code, I have to assume. Any Vue people here? You weren't the first hand. Any questions? Okay, we're done really learning something. These are like holy wars that I want to wage. But let's do some more learnings and see what we got going on. Does anyone, I can't do math while I'm on stage. Does anyone have any idea of how much actual time we have left? 13 minutes? Oh, we got plenty of time. Can you infer the meaning of this? Don't look at the bottom. Let me highlight it so you can't see it. T, K, blah, 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 terrible types that we don't like. L and K of U infers U, blah, blah, blah. We don't like those. We don't use variables like that in this home. We use good stuff. So this is a type that is set optional. It creates a type that makes the given keys optional. The remaining keys are kept as is. This gets around our problem of mapped types uniformly acting, right? We've seen this trick a little before, right? We like decide we want to act on a subset of keys, so we keep our initial object and intersect it with a sub map. So we got base type, we got keys that are base type, the keys of base type. Just pick the keys that are not optional from the base type. So once again, like this is like set optional thing and give me the keys you want to be optional. So for the base type, pick and exclude the keys that we're going to act on. So get what we had before that we don't care about. Intersect that with a pick of the keys that should be optional, and make them partial. So a partial of a pick of the base type of the keys you passed in, and if that extends the inferred type, then for each key, use the new inferred type. So if that's true, then do it. Make them optional. Otherwise, what are you doing? Why'd you pass me this? So once again, that seems crazy. That seems really hard. But that's because that's like code. That's like code that we've written to do something crazy. But this just says for foo, which is A, B, and C, and B is already optional, and C is not, set optional B and C, bam. It works. Pretty cool. Yeah, you see that weird typing here. That's why we need the infer here. We need to see if it's already optional. Any questions on that? Understands infer perfectly now, right? Probably not. I don't either. But now if you see it in your code base, you're not going to run away screaming. You're going to be like, oh, that weird dude in the overalls mentioned this. I'm still going to look it up, but at least I know that infer is a thing. And that's really all the learning we have. I just have one last bit of random advice, which is type versus interface. I feel like I got this question in almost every talk I gave, and so I've just decided to put my foot in. Here are my real thoughts. Type, useful for type aliasing. This is the type keyword versus the interface keyword. Type keyword, useful for type aliasing. It's way less characters, and it makes me feel like I'm writing a cool language, like Haskell or F#. You're some nerd from Microsoft. Yeah. Cons, you can't use the extend keyword in it. You can't like extend types, you have to intersect them, right? So I can't make animal type, I can't do classical polymorphism, right? Interface keyword, pros, can extend. Cons, and pros also, it makes like Java people feel more comfortable. They're like, oh, okay, we got types now. I know how to write code again. Cons, so many characters. My fingers hurt. Wears out the keyboard. Makes me feel like I'm writing Java, which hurts my soul. Much more important than the keyboard. But, you know, I can make my little line that has its little grr. If you're writing code like this in the year of our Lord 2023, bless. My recommendation is like someone has obviously made this in your code base before, and if you have both of them, like if you're like, you know, this is all sorts of coding things. If like some people are doing one thing, some people are doing the other in a code base, that doesn't matter. In reality, you need to be consistent because you're going to confuse new people. It's just going to make your code base less maintainable. Just choose one and stick with it. I'm currently in an interface. I'm in an interface code base right now where all the interfaces start with I, and it makes me not like my job. It's awful. But I'm working with some dude that learned how to code like .NET 2, and it makes him feel comfy, and I'm compromising because we're a team. So stay consistent, but I think we all know the cooler one. There's some more examples here. Yeah. We can do it real quick. I did not listen when we were told the time. Let's tie it all together. Require at least one. Blah, 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 blah. Where'd it go? Yeah. We're going to make a giant type. We're going to make a giant, awful, scary type. And it's going to need like 5 subtypes. So, what does pick do? We all know pick by now. It is a map type that gets a certain subset of types, right? Just grab me, only the things I want, and give them to me. So pick, user and email, gives me email your first name. Except, we know this, it does the opposite of pick. It says, give me all the things except the ones that I asked for. So user without ID is except of user and ID. Required, we all know, because it takes off, it's a map type that takes off the question mark operator off of a type, makes everything required. That's all easy. We all know that by now. We've gotten the value out of our conference ticket because we know these things. Oh yeah, we've been through this. This is an old slide. Anyways, that was a little embarrassing. Closing time. Thanks for listening. Thank you for listening to this talk. I like to think that it helps people get associated with the scary parts of TypeScript. What I recommend is going to these resources. They're very good. And just looking at these types. Like I guarantee you, if you go to the Typefest library and you learn, oh, don't worry, there'll be a link that will help you. I'll even just pull it up right now because it'll be better. This is the link to the slides again. I highly recommend reading that blog. Marius Schultz is the reason I know TypeScript. And feel free to ask me questions. But yeah, if I want you to take anything away from this, it's like, don't be afraid. Oh. Didn't work. Yeah, just play around with it. TypeScript is your friend at the end of the day. That's all. Any questions? Bam. Pat.
I was just curious, I saw some like advanced type function type stuff. Do you have any examples of recursion in type?
No, but I have done that. I was working for a client that was very picky about it, so I did not include it, but we can't talk about that. You can recurse with types, and they recently just made it much more optimized. It used to like stack explode really fast because it's a type system, and they didn't think anyone would be dumb enough to do that. But they implemented like they let you do tail end recursion in the type system now. It's a ridiculous thing. So yeah, we could talk about that. I should include that, but yeah, I didn't at the time. You had your hand up, maybe? No? Yeah, I thought you did. Okay. Well, thanks, friends. It's been great.